Hi everyone. This is to repeat what I did today because of the problems we have in the program. Okay, so this seminar is basically to replace the one that we did today together. Okay, so here we have this circuit, and we want to find VC. So the first thing that we need to do here is trying to convert the circuit into a phasor equivalent circuit. Okay, so we cannot keep it in the time domain, but we have to change it to the phasor. So here we can see this is 10 sine 1000 t. We see that we cannot keep it in sine, so this has to be in cosine. So to convert it into cosine, so this is 10 cosine 1000 t minus 90. So here we have to take out minus 90. So this becomes 10 angle of minus 90. Then we need to change the inductor to j omega L, which is basically j times what is omega? Omega is the frequency which is dictated by the source. So this is j times 1000 times zero point 0.1, which is j 100. The resistance, as usual, we don't touch it. So we come finally to the capacitor, which is minus j over omega c, which is equal to minus j divided by omega, which is 1000, times c, which is 10 times 10 to minus 6, because we have to convert the microfarad into farad, and this is equal to minus j 100. So with this, we are done. This is my circuit. Now I want to find VC. So we will solve this question using two different approaches. The first approach, the one in the notes, which is we will find the equivalence of this parallel combination, and then we will have two impedances in series, so we will apply voltage division. Okay, so here we will call this, so this circuit becomes equal like this: 10 angle of minus 90 j 100, and this is what I will call ZC. And ZC basically nothing but the 100 ohm and the minus j100 ohm in parallel. So this ZC will equal to 100 in parallel with minus j100. So this is equal to 100 times minus j100 divided by their summation, which is 100 minus j100. So we can take the 100 as a common factor. So this becomes 100 times minus j100, and we will have here another 100, 1 minus j, so this will cancel. So we have minus j100 divided by 1 minus j, and if you do that, you will find this is equal to 50 minus j 50, and this is equal also to 70.71 angle of minus 45. So this is your ZC. Okay, please do the calculations yourself to make sure that you reach to these numbers. Now we will apply a voltage division. What is a voltage division? We have a voltage source in series with two impedances in series. So your VC is nothing but this voltage. Your VC is the same as this VC. So your VC will equal to the main source, which is the 10 angle of minus 90 times ZC divided by ZC plus J100, because now ZC representing this whole impedance is in series with the J100. Now we know what is ZC, so we'll multiply 10 angle of minus 90 times the ZC, which is 70.71 angle of minus 45 divided by ZC. Now I will keep ZC in the rectangle because here I'm adding. Okay, so when you add, it's better to keep it in rectangular. This is why I have it in both, in rectangular and in polar. So ZC now is 50 minus J50 plus J100. Okay, so now in the numerator, we have multiplication of two polar numbers. So this becomes 7 or oh, keep it as it is. Doesn't really matter because we will have something nice now. 10 angle of minus 90 times 70.71 angle of minus 45 divided by 50, then minus J50 plus J100. So this is plus J100. Now, when we convert this into polar, this becomes 70.71 angle of 45. So this will cancel. So we'll have 10, and then we will add the angle. Minus 90 plus minus 45 minus 45. So this is becomes minus 180. So this is your VC, and then we can convert this because remember we want VC of t. So your VC of t will equal to 10, the magnitude, cosine omega, which is 1000 t minus 180. So this is one way how to solve the question. Let's think about or see another way, which is using the nodal analysis. Sometimes the nodal analysis is really very helpful. So this is the solution. Okay, so I will redraw the circuit for you here. So here we have the voltage, which is 10 minus 90. Then we will have the J100, the 100 here, and the minus J100. Okay, excellent. So now what we want to do, we want to find VC. What is VC? VC is this voltage. So basically it's the voltage between this point and that point. If we assume this is the ground, or this is my reference where V equal to 0 for the nodal, so I will use nodal analysis. So this is your VC. So we'll have basically 1, 2, 3 nodes. This is the reference. This is we know. So we have unknown here. So apply KCL at, let me call this is node 1, at 1. So we'll assume the currents as usual are all leaving. So we assume all the currents here are leaving. So we'll have VC minus 10 angle of minus 90 divided by J100 plus VC minus 0 divided by 100, which is this current that goes down. And then this is the other current plus VC divided by minus J100 equal to 0. So we have one equation, one unknown. It's very straightforward. Now here's a hint. The best way to approach this problem, you want to get rid of any J in the denominator. So one way to do that, I will multiply the whole equation by J100. So J100 times this becomes VC minus 10 angle of minus 90 plus J100 divided by 100. So this becomes JVC. And then this will cancel. I have minus VC equal to 0. So we have this will cancel with this. So we'll have JVC equal to 10 angle of minus 90. But what is J in rectangular if I convert that into polar? Or let's do it step by step. So VC is equal to 10 angle of minus 90 divided by J, which is equal to 10 angle of minus 90 divided by 1 angle of 90, which is equal to 10 angle of minus 180, which is exactly the same answer that we had before. So here, obviously, nodal will be your pick. This is the best way to solve the question, but it's not always the case, okay? So it's good to know a couple of techniques, but as I said, in the final, you will not be required to use any specific technique in your solution. Okay, so now let's see this question here. Now, this is like more of a typical exam question here. This is what you expect to see in the exam. So what do we have here? We will have V1. So this is one node V1, and here we ask to find use nodal. I want to find V1 of t. This is V2. The ground is given to you here. And here we have two sources. The first thing here that we need to pay attention that although we have two sources, we have only one frequency. And we mentioned that before. For AC analysis to be valuable or to be to be able to apply the phasor principles here, we have to have only one frequency. If we have different frequencies, we cannot do this. So here omega is equal to 100 radian per second. Okay, now this is sine. I cannot keep it as a sine, so I will convert this first to cosine. So this becomes 2 cosine 100t minus 90. So this is 2 angle of minus 90. This is already in the cosine, so this is 1.5 angle of 0. Now we have here, this is j omega L. Omega is 100, so this becomes j 100 times 0.1, which is j 10. Okay, and finally the capacitor here, it is equal to minus j over omega, which is 100 times 2000 times 10 to minus 6, and this is minus j5. Okay, I'm set. I converted the sources into their phasor representation. I converted the capacitor and the inductor into ohms. Is as we know, it is a complex impedance. Then I am set to start solving the question. So this is my question now ready. Sometimes, as I mentioned before, you might have the question already in that format. Then you don't need to do any conversion and you can start right away solving the question. So here we have two nodes, V1 and V2, and this is the reference. So we apply KCL at V1. So we'll assume the currents are leaving, except if the current are given to us as a current source. This I cannot change its direction. So the current that goes down here, so it is V1 divided by 10 plus V1 minus V2, the current that goes to the right, divided by minus J5. Now this current is entering the node, so I will say this is equal to 2 angle of minus 90. Also KCL at V2. Now we'll assume again the currents are leaving, regardless what have assumed in the previous step. Still, I can assume the currents are leaving, as we did that before many times. So the current to the left, V2 minus V1 divided by minus J5. The current that goes down here plus V2 divided by J10 equal to 1.5 angle of 0. Now we are done with the electrical engineering part. Here now, from now on, all math. Now this is the most difficult thing you can get in the final. Two simultaneous equation with two unknowns in complex number. Okay, so here you have to be careful how to deal with these types of questions so that you will not, go astray when you try to solve the math. So here, let's start here. Now, as I said, as a rule of thumb, try to make, there is no j in the numerator, in the denominator, and it's better to make the denominator always 1. Okay, so here I will multiply by 10. So we multiply by 10, this become V1 plus 10 divided by minus, so this becomes V1 minus V2 times 2 divided by minus J equal to 20 angle of minus 90. Now, I will multiply this by J over J. Okay, so if this is the case, J over J, J times J becomes -1, -1, so it becomes +1. So this becomes V1 plus J2, V1 minus V2 equal to 20 angle of minus 90. And this is equation number 1 ready, meaning that there is no denominator. I'm getting rid from any denominator and I have it in that format. Let's see this one here. So in this equation, what I will do, I will try to I will multiply this by J10. So if this is the case, multiply this by J10. So J10 divided by minus J5, this we have minus 2, V2 minus V1 plus V2 equal to, now J10, what is J10? J10 is 10 angle of 90. So when I multiply this with this, so I will get here 15 angle of 90. So this now become my second equation, number 2. Now we need the equations already, but still we have the two equations now, need to handle them. How to handle them? We have to eliminate one of the variables. Okay, so the easiest one here, let's see here. Let me collect terms here. Let's see equation number 1. Equation number 1 is basically minus J2V2 plus V1 of 1 plus J2 equal to 20 angle of minus 90. And if we equation number 2 here, so minus 2V2 plus V2, so this becomes minus V2, and for V1 plus 2V1 equal to the 15 angle of 90. So now we have these two equations. So I want to eliminate, it's easier to eliminate V2. So I will multiply here, equation number 2. I will multiply it by minus J2. Okay, so this becomes plus J2V2, because when I multiply this with minus J2, this is what we have here. Okay, minus J4V1 equal to, now when this is multiplied, I multiply this by minus J2. But what is minus J2? It's basically 2 angle of minus 90. Okay, I will multiply 2 angle of minus 90 times this, so we'll get here 30. 2 times 15 is 30. 90 minus 90, this becomes 0 or 30 simply. So now we have these two equations, this equation and this, we just add them. Okay, so if you will add this equation, I will call this is 3 and this is 4. So we will add 3 plus 4. Okay, so when we add these two equations, this will cancel with this. And we'll have V1 times this and this. So this becomes your V1 of 1 minus J2 equal to, this is 20 angle of minus 90, or minus J20 plus 30. So from this, your V1 is equal to 30 minus J20 divided by 1 minus J2. And then you can calculate this, and you will find that this is equal to 16.098 angle of 29.7. Again, I urge you, please go there and try to solve this question. So with this, now we are done with the notes what the two examples we are supposed to go. Now, I wanted to give you a bonus question, but unfortunately, because of what happened, I couldn't. So I will give you now the bonus question. I created a folder called bonus AC question. So please, when you see this, try to solve it. I will draw the circuit to you here. Try to solve this question and upload your answer there to get your bonus mark. So basically here what we have, again, this is a typical exam problem. Okay, so this is 10 angle of 30. We have here a resistance 4 ohm. Here we have minus J2, and we have here inductor with J1, and then we have a dependent current source, something we didn't see for a while. So this is good to refresh your memory. Ix. And what is Ix? Ix is this current. So this is a dependent source that depends on another variable in the circuit, which is Ix. Here we have V1 and V2. The question here says find, you need to find V1 and V2. Okay, so this is your reference here. This is V equal to 0 to make things easier for you. So basically you have this node and this node. Okay, so you need to apply nodal. Nodal is the straightforward, or this is the way you should go. And you need to find for me V1 and V2 using nodal analysis or any other, but this is the best way to solve the question. Okay, so with this I will conclude my lecture today. I will stop the recording, and this is the one that I will be posting for you.